కొంచెం ఫేస్ ఓకే సార్.
Good morning friends. Today in this video, in this lecture, we'll discuss a case of minimizing function z equal to 5x1 plus 7x2. This function is subjecting to constrained by three constraints, let us say c1, c2, c3. c1 is x1 plus 3x2 greater than or equal to 6, 5x1 plus 2x2 greater than or equal to 10, and x2 is than or equal to 4. And we have another constraint stating that x1 and x2 must be always positive. That's why this is, we call it as a non-negative restriction or constraint. Non-negative restriction or constraint. Or this objective function, the constraint 1, constraint 2, constraint 3 are all the form of lines, are all the form of equation of a line. To draw a line, we need either slope or at least 2 points. So now we'll use that simple methodology, generating 2 points. For the constraint 1, if you look at this equation, the constraint 1 is combination of x1 plus x2 equal to 6 and then greater than 6. That can be rewritten as in these 2 forms. So now we'll use the form of x1 plus x2 equal to 6, which is a part of that constraint. Now for this, set 3x2, x1 plus 3x2, x1 plus 3x2. So now when we substitute x1 0, so x2 is 2 and then x2 is 0, x1 is 6. Now similarly, when we go to the second constraint, when we place x1 as 0, x2 will be 5, x2 0, x1 is 2. So these are all the points on the constraint line 2. Now for the third constraint, x2, see constraint 3, x2 is always irrespective of x1 value, always it will be 4, but otherwise it will be less than 4. Now the maximum value, if you try to look at here, x1 is 6, so x2 is 5. So x1 we are trying to now place on x-axis, and now we wanted to have x2 on y-axis. So by placing the variables, for the values of the variables for the constraint 1, c1 0 2 0 2, somewhere here this is all approximate only 0 2. If you use graph, if it is provided by the examiner, when you are writing examination, please use graph, otherwise go as approximate graph by manual way of representing your equation. So now 0 2, then 6 0, that is the maximum for us here. So connect these 2 points, this is the line, is the form of x1 plus 3x2 equal to 6. We are interested, apart from the equality, also greater than. So now the points which will be lying this side of this line are satisfying x1 plus 3x2 greater than or equal to 6 up to the line. Now to draw the other constraint, we have other 2 points, 0 5, so 0 5 somewhere here, and then we have a 2 0. Connect these two, that is your constraint c2. Now this is also greater than or equal to 0. Now all the points which will be falling this side will be satisfying 5x1 plus 2x2 greater than or equal to 0. To identify the area, pick up any point of any side of this equation, you will be easily identify the area which side this particular constraint will be satisfied. Let us say now somewhere here, so this is 3 and 2, so let us say it is 3 and 3. Somewhere here 3 and 3. So when you substitute here 3 and 3, so 5 to 3, 15, so that itself is greater than, so automatically the area which is this side will be satisfying that particular constraint. Now we have other equation here, x2 is always less than or equal to 4. So now 0, 4, somewhere here, draw a horizontal line through this 0, 4, that is your constraint x2 less than or equal to 4. Now the area which is bounded by this all constraint lines, which is your feasible solution space. This is your now feasible region of constraints. Now let us name this as a the boundary points B and C. So now we know A already, which is 6, 0. To find the point B, we need to solve, we need this intersection of constraint 1 and then constraint 2. Constraint 1 and constraint 2. To identify that, use your equation system. X1 plus 3x2 equal to 6, 5x1 plus 2x2 equal to 10. Now multiplied by 5, this subtract it from the next equation. So 5x1 plus 3x2 equal to 15x2 plus equal to 30. So 5x1 plus 2x2 equal to 10. By subtracting, we are getting 30x2 equal to 20, x2 equal to 20 by 30. By substituting this in equation 1 or 2, you will be getting x1 as 18 by 3. x1 as 18 by 3. So now the B is 18 by 3. Sorry, 30, 20 by 30. 18 by 30, 20 by 30. Now for obtaining the point C, which is intersection point of constraint 2 and then constraint 3. So we know that on this line always x2 is 4. So now for obtaining the value of x1, place by substituting the 4 in your constraint 2. So 5x1 plus 2 into 4, 8. So that is 5x1 equal to 10 minus 8. 5x1 equal to 10 minus 8 to x1 equal to 2 by 5. This is for the point C, which is your 2 by 5 comma 4. Now to draw the objective line in the same graph, we need to, this is also a line form of the equation. So for this we'll use the slope of the equation, or otherwise we can also generate 2 points for this particular equation. So let us say z, when it is passes through the horizon, this is also one of the point in your region. So z equal to 0. So this is written as 5x1 plus 7x2 equal to 0. This can be written as x2 equal to minus 5 by 7 x1. So your slope value is here. So now that when you wanted to draw here, minus 5 by 7, so minus 7 and then 5. So somewhere here, this is your, draw the line through the horizon and this point. This is your z objective line. Now move this line into the feasible solution space, feasible region. Now wherever it enters, it touches the first time the feasible solution space, that is the point which will be giving you minimum value. It is clear indication here, it is z z equal to, sorry, x1 when it touches b, when it is touching the b, it will be the first point of the equation. So z value at b, which is 5 into 18 by 3, 30 plus 7 multiplied by 20 by 13, which gives you the optimal value of your objective equation. This is your minimum z function. So the value at b, the value of your z at b is minimum. So b is the optimal point for generating minimal value of objective function. Thank you.